Thank you for joining me in this presentation. In this presentation, I'll be talking about a generalized model interface. Most Excel users use formula based on cell links. There's a limited understanding of effective use of name ranges. Excel workbooks become messy. This presentation focuses on automatic methods of applying models. These models can be constructed in native Excel. In this presentation, it'll be about a general Excel model interface. What's critical is that the models are well defined. Data sets are represented using name ranges, and by doing this approach, it's much faster to apply models to new data sets. Foundational concept, I'm not going to go into them here. I have provided them in LinkedIn, where I discuss the foundational concepts of a model and what I call a process model. A model is an entity representing a well-described set of equations. It should be a mathematical model, a computational model, and a visual model. Please see the following link to discuss modeling in more depth. A process model, I call that a higher level than a model. So it's a set of linked models. And there is the link. In this presentation, I'm focusing on the model interface rather than process modeling. I provide a modeling method based on native Excel rather than VBA. Now, I recognize that VBA is preferred to native Excel, but many quantitative professionals, engineers, financial modelers, scientists, and so forth, are unfamiliar with VBA. Hence, I'm actually introducing model concepts into native Excel to non-VBA users. And it also provides a platform to later explain the purpose of VBA. A mathematical model should consist of a name, clearly defined variables and their description, clearly defined linkages between equations, clearly defined scope, and clearly defined description, including reference links. For later integration into a flowsheet system or a process modeling system, a model should have a shape that it's associated with. This allows visualization and later integration into a process model. So this is the idea, and it's very straightforward. A model has inputs, control variables, and outputs. Control variables generally relate to the user interface. The collation of control variables in a single worksheet is generally called a dashboard. So mineral processing, here's an example. Overflow and underflow are outputs. A classification curve defines the model, and the feed is what goes into the unit. So it's very important. This is where I vary from standard Excel usage, in that I have a template which defines what a model is, its properties. I won't go through this in too much depth, other than to say it has a strict lookup table to identify the inputs and the outputs. Here we see an existing template, but I want to create a new template. Now, I've created a ribbon interface with quite a lot of options. The main options are here on the right. I use a library, and there's a choice of libraries, but a library is a collection of models within the same workbook. So if I want to create a new model, I press create. I give it a name. Here I call it new model. And I'll just add two control variables or name ranges, two input name ranges, two internal name ranges, and two output name ranges. Now, an internal name range is one which is both updated but also used by other name ranges. we see that I've created a template for a new model called new model. So here I'm going to discuss how you would actually change a model from being applied from one set of data to another. Now, you've got to understand that there are quite a number of templates involved in this model system. So, cyclone template actually gives an example of how the equation is applied. Now, I don't want to explain the model in detail other than to say we're using an array formula to relate the underflow to the feed and the classifier efficiency. So if I go back to the model template here, it tells me the name of the name ranges that are part of the model, the inputs, the control parameters, the internal name ranges, and the template. Now, clearly, this does take a while to set up, and it forces you to be very clear about what the inputs and the outputs are. So it's not a 5-minute job. It does in fact take some time, but once you've done it, you can automate application of the model. Now, here it says what the template file is, and here it says what the model is currently being applied to. Now, if we change it, it won't upset existing uses of the equation, unless you particularly, if you use it on a new data set entirely. Now, it isn't as easy as just pressing a button and expecting the model to run. One of the underlying difficulties, which appears to occur more in engineering and science than in, say, financial modelling, is when you have a variable structure versus a fixed structure. Applying models to new data is moderately straightforward when data is fixed. The situation is complex when the data structure is variable. So there has to be more models required to relate the structure of the output to the structure of the input. For example, the size of the output to the size of the input. And if you like, these little sub-models are part of the main model. So not only do I have a template for the main model, I also have templates to describe what the resulting sizes of the outputs and internal streams will be. So here I simply say that these tables give the structure, and I have a function which basically says the number of rows of the underflow equals the number of rows of the feed. So these have to be set up as well. And if we look here, there's a button which says set ranges, which we can apply to create the actual ranges, just using those table structures. So in this example, I'm just going to show you how the model is applied. This is the data that the model will be applied to. And you can see that there's, here's the template, and I've specified where the outputs will go to in current. So for each of the particular inputs and outputs, you have current. So here we see where I'm going to put them to, and there's no data. There's no models being applied currently, but we want to apply the model. So we simply say apply, we want to apply the cyclone model, it runs, we have a look at it, and look, all the equations are now applied. So it's a very simple framework, and obviously to do this from scratch would possibly take a person about an hour. So it's fairly easy to apply the model to new data. We can do this by either typing the name ranges in the template or using the interface. And of course beneath this there's VBA code, so it can be done through VBA. The model is easily applied by reading the equations from the templates and replacing the template name ranges with the new name ranges and writing equations to the output name ranges. The whole approach is reasonably straightforward if one uses name ranges. It's really quite complex if you don't use name ranges. And there is guidance on how this can be done, but really I would avoid it. In fact, cell links are contradictory to the whole structured approach. And this is why these methods are quite different to a lot of the conventions. The model interface has been constructed. Alpha versions are available for $15 US. You have to contact me at my email. It will take time to get it running, but once you've done it, you can set up libraries and apply lots of models. The methodology will be integrated into the general Excel flowsheet process modeling system to be released later, and subject to whether or not there's interest.